Thank you, Igor. Hello, everyone. Today I'm gonna show you the whole process from robot cell creation to NC program launching using SprutCAM Robot. Here is the plan of our webinar. MachineMaker is the main part of our webinar. I will demonstrate you how to assemble robot cell in new application called MachineMaker, how to calibrate tools and workpiece, how to calculate tool connection point using mobile app, how to create simple NC program in SprutCAM, and how to launch it on a real robot. After all, we'll answer your questions. Please write your questions to chat. So, what is MachineMaker? MachineMaker is a new application, allows you to assemble robot cells and export it to SprutCAM by one click. You can import 3D models of robots, rails, rotary tables, and other objects, then assemble robot cell using datasheets, and finally export created schema to SprutCAM. MachineMaker convert CAD files to SprutCAM OSD format, generate XML file descriptor, and make preview image. MachineMaker is free in SprutCAM 15 and is available with any license. Using robot calibration app for mobile phones, you can easily calculate tool connection point. So here you can see the example of XML file descriptor. Using MachineMaker, you don't need to write code or edit XML files at all. MachineMaker will do this for you and will generate absolutely correct XML file. Now MachineMaker supports 6-axis robots, heavy-duty robots, cobots, end effectors, fixed objects, tables, 1 and 2-axis rotary tables, rails, and 2 and 3-axis portals. Now we are working on 3 and 5-axis milling machines and 7-axis robots. Milling machines and 7-axis robots support will be added in SprutCAM 16. Here you can see the list of 23 supported robot vendors. If you want to add another robot vendor to MachineMaker, please text us. And today we will assemble KUKA robot. A few words about import. Current MachineMaker version can import 3D models in STEP, IGES, Parasolid, SprutCAM, OpenGL string data, Arena, STL, GTOpen, SolidWorks, and Solid Edge formats. Simplifier. It's one of the main features of MachineMaker. MachineMaker has embedded 3D model simplifier. Look at this spindle 3D model. Left one looks like right one, but right one has simplified and contains less faces. So SprutCAM can work much faster with this 3D model. It works when you import any 3D model. MachineMaker delete all invisible faces and small objects. So intro about MachineMaker is finished. Let's create new robot cell. Open SprutCAM, go to applications, and run MachineMaker by clicking this button. Okay, we can see MachineMaker. So this is main toolbar. Here you can see main menu button, usual create new, open existing, and save project buttons. This is settings button where you can set language, visualization quality, set SprutCAM path, and another options. This is run simulation button where you can run simulation and validation of your robot cell. This is assembly settings button, and clicking this button you can export your robot cell to SprutCAM by one click. This is robot name. This is our project name. You can change by double click. So at the right side of toolbar, we can see two buttons. This is online help button. Let's open it. Here you can find detailed documentation and a lot of examples for MachineMaker. Okay, let's see. There are many tutorial videos and animated pictures here, so it is really easy to understand. Please use this online help. I recommend it. Okay. And the last button is send feedback button. If you have any ideas or any troubles about MachineMaker, please feel free to text us. Just text your request here and send by clicking this button. Okay, also you can see here view controls. This is just rotate buttons, rotate view. This is rotation mode. This is constraint rotation mode. Please look at Z-axis. If you click another time, it's free rotate mode, like in SprutCAM. I prefer constraint rotate X mode. It's more convenient for me. And the last one is zoom all button. Okay, let's create new robot cell. Here you can see add mechanism button. This is the main button. First of all, I will add robot to our project. I click robot, and now I have to select robot 3D model. I have downloaded 3D model. I got this from KUKA download center. It's absolutely free. I select it and open it. Now MachineMaker import this 3D model and simplify it. Okay, import is complete. We see robot 3D model. We see base node here and 6 joint nodes also. So now we must group our robot parts to robot nodes. We just click here, select base node. I start from base node and just select all parts we want to include to our project. Okay, I click here and here. If you don't want to include some parts, just don't select it. For example, I don't want to include these wires, so I just don't select it. So I think base node is complete. I just go to joint 1, I select it, and I select joint 1 parts, just one part. Then joint 2, 3, 4, 5, and the last one. Okay. Group. We just group parts to robot nodes. Also, you can set name of your mechanism here, and you can set robot vendor here. As you can see the list, I select KUKA robot because we have KUKA robot, and I click next, and we go to kinematic tab. Here we must set correct robot dimensions. Where we can get these dimensions? I get it from robot datasheet. I download it also from KUKA download center. Okay, this is it. This is robot dimensions, and this is axis limits. Let's put these dimensions to the kinematic. Okay, you can change these values by clicking and rotate your mouse wheel, or put by keyboard. I use keyboard. Okay, first dimension, second, 55, 515, 90. Okay, dimensions is done. Let's check it. Okay, I think it's okay. And now we must set correct axis limits. I also take this correct data from robot datasheet and just input. Okay, everything is okay. After that, I go to simulation tab, where I can check, validate what I just entered. I can use these sliders and check manually, or I can just click this demo button, and this button will validate all axes. Looks like everything is okay. Okay. I go to Style tab. Here I can set colors for each joint. You can select sets, for example, KUKA, Motoman, or another one. But I select 3D model colors. This is actual colors for our robot. Okay, I click apply. That's all. We just added robot to our robot cell. After that, I add our table. I click add mechanism, select fixed table, and select 3D model of table. We made this 3D model in CAD system. Import is complete. Okay, we see our table. Here we also select all parts we want to import to our project. All parts are imported by default, so I just click next to kinematic tab, and here I must to set correct this point to correct place where we want to install our robot. We will install our robot to this plate. Okay, let's check. Looks like everything is okay. Okay, go to next tab, style. Here I select another color for our table. For example, our robot is brown. Okay, and that's all. I click apply, and we just add table to our project. Now I want to put our robot to table, to this place. How can I do this? I just hold left control and I see all connection points of our project, and I use drag and drop and to place robot to this place. Okay, that's all. Last thing I want to do is to rotate our robot to correct position. I select robot and set rotation position to this. Okay, that's all. Also, we can check simulation for the whole project. Everything's fine. Okay. The last mechanism is end effector for our robot. I go to add mechanism, end effector, select end effector 3D model. Okay, import is working. Okay, import is complete. All parts of our end effector is already selected. I just need to rotate end effector to correct position to robot flange. Okay, just rotate. Okay. Looks like everything is okay. Here you can set type of end effector. I select mill holder type, mill tool holder, sorry, and I click next to TCP tab. Here you can see tool, drill tool. We have to place this tool to tool connection point. First of all, I just rotate this tool, okay, and put this tool to TCP by drop down, drag and drop, sorry. Okay, that's all. Let's check. It's fine. So we just place tool to TCP, but this is theoretical position of TCP, tool connection point. You must do tool calibration for calculate correct actual position of tool connection point. Okay, a few words about tool connection point. So this is TCP. Okay. Few seconds, please. Okay. TCP has XYZ coordinates and ABC angles relative to robot flange. We suggest you to use calibration by short and long tool. After short tool calibration, we get this point. After long tool calibration, we get another point. And if we have these 2 points, we can easily calculate tool connection point and axis direction. Okay, Igor, please start tool calibration video. Okay. We made a video because calibration process is too long for webinar. Now we can see tool calibration process. We use calibration by 4 points. Now you can see calibration for long tool. This tool is moved to calibration pin from 4 different sites. Okay, this is third site. And the last one. Okay, long tool calibration is done. We just got XYZ coordinates of long tool tip. And now you can see calibration with short tool. Please note that the greater the difference between short and long tool length, the more accurate the TCP calibration result. We do short tool scenario calibration to the same scenario from 4 different sites. So the last one, and we got XYZ coordinates of short tooltip. Okay. So after calibration, we have 2 points. One is for long tool and another one is for short tool. Now we have to calibrate TCP with our new mobile app, robot calibration. Okay, I take my phone and I start app on my phone, and I go to our robot. Igor, please tell our viewers what I will do.
Okay. Now Alexander go in our robot cell, and we see it in the left screen. He made a photo with data for short tools, short tool. You see it in the right screen, right part of screen. His choice XYZ coordinations, and now he takes a photo for long tool, and again choice data for long tool. Now Alexander, come back.
Okay, I'm here. Okay, it took less than 1 minute. I just click calculate, and now we have TCP coordinates and axis direction. Please note, you must enter ABC values to the tool transformation on the robot controller for tool you will use. We will use short tool for workpiece calibration, so we will enter ABC values to short tool transformation. Okay, now I'm gonna put TCP values to MachineMaker. It's very easy to do it. I just press send button on the phone and scan QR code from MachineMaker. Sorry. Okay. As you can see, values are changed, and this is correct actual position of our tool, and this is a little bit difference from the theoretical position. So that's all. I click apply, and our work cell, our robot cell is done.
It's very easy.
Yes, I just reset table position. Okay, that's all, and we are ready to export this robot cell to SprutCAM. I just click this button. I click folder for save my project, and we see our robot cell in SprutCAM. So we are ready to create some program for our robot. I want robot to write simple word on a A4 paper. Let's create A4 sheet as workpiece. So SprutCAM has simple CAD editor. I go to model, design, and create box by 2 points. dimensions for the sheet, and I set thickness to 1 millimeter. Okay, workpiece is done. Now let's set a coordinate system for our workpiece. I hope you see this. 1 second. I just change my position. Okay, we can create coordinate system by this button. Create new coordinate system by starting point x and y axis. Okay, origin, x direction and y direction. That's all. Coordinate system for workpiece is done. Okay, I go to machining. So now we have to define our workpiece location relative to the robot. How we can do that? We need to make the workpiece calibration on the robot. Igor, please start the workpiece calibration video. Okay. Note that calibration is carried out with an already calibrated tool. It's very important. You must put ABC values for the tool you are using during the base calibration. Okay, we use base calibration by 3 points. We defined workpiece coordinate system earlier, and you can see it's on the sheet. First of all, we directing tip of the tool to the coordinate system origin. After that, we define x-axis direction, and finally we define y-axis direction. Okay. After calibration, robot will display as workpiece location relative to the robot coordinate system. Okay. Yes. 1 second, please. Okay. Now we can enter these values to base setup. I go to base setup. I select our workpiece coordinate system. I select robot coordinate system, and I put values here. X value, Y, and Z, and the angles. So that's all. This is actual position of our workpiece. And also I set base. I select coordinate system of our workpiece. Okay. Now I'm ready to create some operation. I want to robot write some simple word, as I said. I go to model, text, and let's write SprutCAM word. I go to font, set a little bit bigger, change position. Okay. To the center of the A4 sheet. Okay. I go to machining and let's create operation. I will use 3D contouring operation. Okay. So let's set job assignment. I just select all letters of this word and click curve. That's all. SprutCAM create curves for each letter. I go to Strategy tab and I disable this option for ensure that robot will write letters on this order. Okay. Next, I go to links and lists tab. Here I set exit overlap for 2 millimeters to ensure that all letters contours will be enclosed. So after that I go to Tool tab. Robot will write letters by red marker. So now I want to set this tool looks like real marker. I set tool type like engraver. Diameter is 11 millimeters. Length is 83 millimeters. I just measured length from collet to market tip, and this is 83 millimeters. So I set angle to 10, and diameter is 1 millimeter. So I think it looks like the real marker. So next I go to Fits and Speeds tab. I disable spindle and I set work fit to 1000. Okay, I think we are ready to generate toolpath. Let's try to do it. Okay, we can see some collisions, I think. I go to axis map to see what's wrong. Okay, we see that we have out of limits collisions. How we can fix this? We can just click this button and SprutCAM will generate correct path automatically, or we can set axis angles manually. I will do this manually. I will set axis 5 angles for minus 40 degrees. Let's regenerate, and that's okay. We get the toolpath. Okay, set maybe A6 axis to minus 10 degrees, and okay, I like it. Okay, last thing I want to change is to change safe level. I go to links and lists tab and change safe level position. I want to place safe level a little bit closer to the word. Okay, I think it's fine. Let's regenerate. And let's check our toolpath in the simulation tab. I go to simulation and click play. Looks like everything is okay. We don't have any collisions. And the robot goes to his home position. Okay, everything is fine. I think we are ready to generate NC program for our robot. I go to machining, post-process. Here I must set correct post-processor file for my robot. I have robot KUKA, so I select KUKA robot post-processor file. After that I click run button, and I get NC program. I click external editor, and here I just comment this line because robot don't know about tool number 26, doesn't know, and I uncomment this line with two parameters. These parameters was calculated by SprutCAM based on TCP and our tool length. So that's all. I think I'm ready to save this program to USB drive.